Welcome to our educational channel, Online Education. We have already uploaded many videos. This is the first video of the series for 10th standard for ncert syllabus. Continue to watch this video which will help you get a clear understanding of this topic. This video is about the periodic classification of elements. Dobinier's triads. Dobinier was a German scientist. He made groups of 3 elements each, having similar chemical properties and called them triads. He arranged the 3 elements in a triad in an increasing order of the atomic mass and showed that atomic mass of the middle element was approximately equal to the mean of the atomic masses of the other 2 elements. However, all the non-elements could not be classified into Dobinier's triads. As you can see in the video, sodium Na has an atomic mass that is equal to the mean of the other 2 elements, that is, lithium and potassium. Newland's octaves. John Newland was an English scientist in 1865. Newland arranged the elements known at that time in an increasing order of their atomic masses. It started with the lightest element, hydrogen, and ended up with thorium. He found that every 8th element had properties similar to those of the first. Example, sodium is the 8th element from lithium, and both have similar properties. Also, magnesium shows similarity to beryllium, and chlorine shows similarity with fluorine. Advantages and disadvantages of octave classification. Advantages. It helps detect a periodic every 8th element pattern in the properties of elements. This classification helped to develop better systems of classification. Disadvantages. This held only true for elements till calcium. Newland assumed that only 56 elements existed in nature, but many more elements were discovered whose properties did not fit into octaves. In order to fit elements into his table, Newland adjusted 2 elements in the same slot and also adjusted some unlike elements under the same slot. The law of octaves worked only well with lighter elements. Mendeleev's periodic table. The Russian scientist Dmitry Mendeleev developed the periodic table of elements during the period of 1869 to 1872 AD. Mendeleev's periodic table is the most important step in the classification of elements. Mendeleev considered the fundamental property of elements, namely the atomic mass, as standard and arranged 63 elements known at that time in an increasing order of their atomic masses. Then he transformed this into a periodic table of elements in accordance with the physical and chemical properties of these elements. Mendeleev found that elements with similar physical and chemical properties repeat after a definite interval. On the basis of this finding, Mendeleev stated the following periodic law. Physical and chemical properties of elements are periodic function of their atomic masses. Dmitry Mendeleev was a professor in St. Petersburg University. He made separate card for every non-element showing its atomic mass. He arranged the cards in accordance with atomic masses and properties of the elements, which resulted in the invention of the periodic table of elements. Mendeleev's periodic table. Mendeleev arranged the known 63 elements in order of their increasing atomic mass and observed regularity in the properties of the elements. Among chemical properties, mainly considered oxides and hydrides. Mendeleev's periodic law. Physical and chemical properties of the elements are periodic functions of their atomic masses. Some merits or achievements of this periodic table was more systematic and easy approached, correction of atomic mass of few elements on the basis of position of the elements in periodic table. Mendeleev corrected atomic masses of few elements. Let's look into more merits of Mendeleev's periodic table. Elements were classified on a more fundamental basis of their atomic masses and properties. Spaces were left vacant to accommodate the elements to be discovered in future. It could predict the properties of elements which helped in discovery of new elements. The inert gas elements discovered later could be placed in a separate group without disturbing the table. Some drawbacks or demerits of Mendeleev's periodic table. Isotopes have separate places in his periodic table. Some elements having higher atomic weight were placed before elements having lower atomic weights. Noble gases do not have place in his periodic table. Elements with different chemical properties are placed in same group while the same properties are placed in different group. The modern periodic table. Using atomic number instead of atomic mass as organizing principle was first proposed by British chemist Henry Moseley in 1913, and it solved anomalies like this one. Lodine has higher atomic number than beryllium. So even though he didn't know why, Mendeleev was right to place it after beryllium after all. So now let's look into the merits of the modern periodic table. Modern periodic table atomic number versus Mendeleev's periodic table atomic mass. All isotopes of the same elements have different masses but same atomic number and occupy the same position. Anomaly regarding CO, cobalt and Ni, nickel disappears. Classification of elements into blocks based on their electronic configuration. So now let's discuss about some demerits of the modern periodic table. Hydrogen resembles both alkali metals and halogens. No fixed positions could be given to hydrogen. Isotopes of same elements have different atomic masses. Each of them should be given a different position. As isotopes are chemically similar, they were given same position. CO, cobalt with higher atomic mass is placed before nickel, Ni. Mn, magnesium, is placed with halogens, which is totally differ in the properties. Now let's learn something more about the modern periodic table. There are 18 vertical groups in the periodic table. Each vertical column is called a group. The groups have numbered from 1 to 18. All elements present in a group have similar electronic configurations and have same number of valence electrons. The elements present in the group 1 and 2 on the left side is called S-block elements, and the elements present in the group 13 to 70 on the right side of the periodic table is called the P-block elements, and the elements present in the group 3 to 12 is called D-block elements, and the elements from lanthanides and N-style actinides is called F-block elements, which are also called the inner transition elements. Thank you so much for watching this video. This was the part 1 of this video. The part 2 of this video will be coming soon. So please subscribe to this YouTube channel and press on the bell icon so that you don't miss a new video from us whenever we upload. Also feel free to ask any questions you want to know in the comment section below.